In the last few lectures, we had learned how to use the turtle module to draw nice pictures. We had also been introduced to iterables like lists and strings. We had learned how to write the for loop and the general rules for writing compound statements in Python. We had also learned how to use the if, elif, else block in order to allow the computation to proceed in different directions depending on whether a condition is true or not. Now, in this lecture, we are going to take a look at how to write our own functions. Now, why do we need to write our own functions? For that, let me show you, or let me bring your attention to what is already there on the screen. I have, of course, started the Python 3 interpreter, executed the standard mantra of importing star from turtle. Then I've set the width to 3. Then I have carried out this loop. Now, every time I want to draw a square, I would actually have to carry out these lines. Now, if I want to make it a regular occupation, drawing lots and lots of squares, and even drawing a lot of squares in different locations can actually be quite interesting, then it pays off to actually have a ready-made way of drawing a square on the screen. For this, let us try to write our own function. So far, we have only relied on functions which have been provided to us, either by things which are already built into Python, or other functions like fd, rt, width, which we have managed to get from turtle. So the turtle module gave us these functions, width, fd, rt. We called them with whatever arguments they needed, and they did whatever they were designed to do. Now what I want to do is write a function on my own, which is going to draw a square on the screen. So for this, let us first show you how to write such a function. So, functions are also written as compound statements, and in this case, the header line of the compound statement for writing a function, a user-defined function, has to start with the keyword def. Def, of course, is short for definition, followed by the name that I want to give the function. Let's say square. And then I will have to put a bracket, a round bracket, and inside that I will have to give the arguments that I want my function to have. So right now I can think of one argument which it should have, which is the side length. Let's just put that in. We will let us see how to embellish this function so that it can have more arguments. But that's for later. For the time being, let's just define a square function which takes in a single argument, which I am calling L. And this is all there is in the header line. As always, the header line in a compound statement in Python has to end with a colon. And in the next line, the body has to be tabbed inwards, indented inwards. So what do you want to be in the body? I want to put in the body whatever I need to draw the square. So here it's pretty straightforward. The body will be for I in range 4 fd, but now this forward command or fd function will have an argument which is not a fixed number, but rather is L. So when I later call the function square, I will give an argument, and this argument value will be passed to this forward or fd function. RT90, and that's it. So this is my simple function for drawing a square on the canvas. Just to remind you, you write the function by starting with the header line, which has the keyword def. All function definitions have to start with def. And then you have to have the name of the function, then a round bracket inside which you put the arguments, or argument as in this case. There's only one single argument. And then inside I have to write whatever the function is supposed to do. And here of course I have a for loop, which is another compound statement nested inside the compound statement which defines the square, which is why the commands fd, l and rt90, which form the body of the square loop, of the for loop, that has to be indented. Those two commands have to be indented twice. And now I have nothing else to do, so I just hit enter, and the function square L has been defined. Note that this has just defined the function square L. This function has been just defined, it has not been executed. So right now there is no new thing which has been drawn on the canvas, but we can actually use this to draw on the canvas in a very simple fashion. Let's just say I call the function now. How do I call it? I just use this name. There's the way in which I have called functions, all the fd, rt, width, all these functions so far, also range. I just write the name of the function followed by a round bracket, and inside the round bracket pair I have to give the argument. In this case the argument simply is the length of the edge. So let's say if I call it with 100, I'm going to get a square of side 100. Of course I did not set the width to 3, the width is 1, so I'm getting a thin line. I hope that's visible. Or maybe let's just set the width to 3 again, and now repeat this. Now I have got the square of 100 with a thick line. The line thickness of course is not something which is a concern of the square function, it has been set externally. But now on top of this I can also draw another square, say of side 200. Of course I am starting at the same corner, the center, that's the corner of the square. So a new square has been drawn. The old square is still on the canvas because I have not reset it, and I now have two squares. Now I can draw squares of arbitrary side length simply by changing the argument. What is more, since I know how to write loops, I can actually use that and the square function to draw some slightly more complicated figures. To see this, let's reset and set the width back to 3. And now what I will do is I will use a square loop, a for loop with L as a variable in the for loop. I had earlier used for I in, but you don't have to call it I. The variable, the loop index can be called anything. Any valid variable name will do. So for L in, let's say so for L in this list, so L will successively take values 10, 20, 30, 40, whatever values are there in the list. That's your header line for variable in iterable. Follow it up with a colon. That's a header line, has to end with a colon. And then inside the body, which has to be indented in, I simply issue the function called square with the argument L. What this means is, first time the loop is run, L takes the value 10, a square of side 10 is drawn, then a square of side 20 will be drawn, then a square of side 30 will be drawn, a square of side 40 will be drawn. So I will see 4 squares on the screen. Rather, let's do one thing. Instead of square L, I will put square L into 5, which means the argument given to the square function is not L, which takes values 10, 20, 30, 40, but L times 5, which is 50, 100, 150 and 200. You'll get to see slightly bigger squares. That's all. Otherwise, not slightly bigger, quite bigger. Otherwise, with 10, 20, 30, 40, the squares would have been very small on the screen. Now, I run the loop. So there's a 50 side square, 100, 150, 200. So do I have to list out all the lengths if I want to draw a lot of squares like this? The answer is no. But to understand that, let's take a look at the range function again. What does range give us? As I explained earlier, range in Python 3 does not give a list directly, it gives a range object. What it is telling you here is that it starts from 0 and its top value is 10. Stop value 10 does not mean it goes up to 10. It's best that you think of this as it keeps on increasing, it keeps on giving higher and higher values, but does not touch the stop value. So it will give you 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and stop there. Just to see this more clearly, let's use a list function to change this range object into a list. So this is the list that we were talking about. Once again, let me remind you that if you are using Python 2, range 10 will have directly given you this list. In Python 3, it gives you something different. What it is, again, we are going to talk about a lot later. But the effect is this. If you range 10 gives you a sequence of numbers which, if you use the list to convert into a list, the list function to convert into a list, will be this particular list. Thus, what happens when you give range only one argument? What happens if you call range without an argument? We have seen that there are some functions we can call without arguments, like reset. Here, if I try doing this, I get an error. The error here it says range expected one arguments, so that's bad grammar, but one arguments, the plural is simply because in general the number of arguments could be more than one, got 0. So giving 0 arguments to range is not a valid option. Fine. I already showed you what happens when you give one argument. You start at 0, 1, 2, 3 and keep on going until you just fall short of your stop value, and that means you will get exactly as many elements in your list as the argument that you have given. But what happens if you give 2? Here, what seems to be obvious is you are asking range to start not at 0 but at 3, and that's right. But what may seem a bit unusual is that it does not give you 8 elements. The stop functions the same way as before. It's a stop signal. So you start at 3, you keep on increasing by 1, 3, 4, 5, 6, 7, and you stop because you are reaching 8 next, and you will not touch 8. So that happens when you give range 2 arguments. What happens if you give it 3? Well, can you give it 3? Let's just check. So here, what will happen is range will give you the numbers 3, that's the start value, 12 is the stop value, remember that's the value it's not going to touch, but increasing in steps of 2. So 3, 5, 7, 9, 11. So the arguments, if you're giving 3 arguments to range, the arguments are respectively start, stop and increment. 3, 3 plus 2, that plus 2, that plus 2, that plus 2, now we have got to 11. Adding 2 to that would have exceeded 12. So you stop. Just to illustrate this once again, if I did this, I will get 3, 6, 9, a 3 element list. I will not get 12, although 12 would have been what you would have got when you added 3 to 9. 12 is a stop value, and range is not going to give you the stop value, it's going to stop short of that. So this is how you create a list starting at a number, going up to something with a given increment. So how do we use that to draw a large number of nested squares? Well, I just have to change the iterable in the, okay, let's call it L, because L stands for length anyway, and let's try to get it directly to be the length. Maybe I want 100, 120, 140, 160, such lengths. So what I will do is this, range 100, that's the starting value. Maybe I want to go up to 300, so I give 301, a number more than 300. Remember, if I had given 300 as a top value, it would have not given you the 300-sided square. And let's say I want 25 as the increment. So here L will take successively values 100, 125, 150 and so on until it reaches 300 and then stop, because your stop value is 301. The next value would have been 325, which is more than the stop value. Of course, I've forgotten to set the width, so it's going to be thin lines, but that's okay. I'm drawing a lot of squares here. Thin lines may be nice. 100, a 125 size square, 150. So you see, this is going on. You're getting more and more squares, and you're done. So 100-sided square, 125, 150, 175, 200, 225, 250, 275, 300. It has just drawn all the squares that you asked it to and stopped. So this is a beginning of how to use functions to make your own code simpler. Notice that if I had not defined the square function, then inside the body of the loop I would have to keep on writing another loop. So inside the for L in range 100, 300, 125 loop, I would have to write another loop for I in range 4. Inside that I would have to write a body and so on. Now in this case, because my function is reasonably simple, writing it out explicitly every time may not be that complicated, but you will definitely agree that having to just type in square L is definitely less work and simpler than having to type in the whole code which square L is supposed to do. In any case, whenever you have to repeat the same thing over and over again, any bunch of function calls, maybe with different arguments, then defining a function which will do that for you and make those changeable things the arguments of the function is quite a nice idea. It helps you to cut down a lot on the work. There are more to defining a function than just this. So let's just see. So what more is there? Well, in the function we define, we have to give an argument. But notice, reset, of course, did not take an argument. Range, on the other hand, could take 0, 1 and 2. Of course, we did not check this, but let's see what happens if I tried 4 arguments. Now I am again getting a type error. It's saying range expected at most 3 arguments, got 4. So from our experiments, we know that range can take 1 argument, 2 arguments or 3 arguments, not more than that. So it definitely is possible to write functions with multiple arguments. And let's just say another argument that I can think of for a square function is the color of the square. So far, I've only drawn black squares, but of course I could have changed the color using the color function that we met in the last lecture, outside the loop or outside the function call, and then got a corresponding colored square. But we can also make this part of the definition of the function. So let's try defining a function again with 2 arguments now. Let's keep on calling it the function square, so the earlier function definition will get overridden. So L comma C. Now we have 2 argument function. And now first thing you do is change the pen color, and then put in the loop which draws the square. So now I have a 2 argument square function. The arguments are the length of the square and the color with which the square will be drawn. But one word of warning now, that if you now try calling the square function the way we did before, will lead to an error, because it says that it's missing one required positional argument. It's missing C. You have given it L, but it doesn't know what C is. Now that our function is defined with 2 arguments, I have to give it 2 arguments for it to work. Okay, so let's try to use this and the idea that we had used in the last lecture by drawing a bunch of multiple squares with different colors each. So let's just put in red, blue and green in that order in a list called colors. Of course, all of these have to be strings, so they have to be put within quotes. Oops. So now I have a colors list drawn. Then I'm going to just repeat the multiple squares figure that we saw a while ago. Maybe I will draw a few more squares, so maybe I will decrease the increment to 10. So now I will get many more squares, 100, 110, 120. These are the values of L until it reaches 300. And what I want to do is I want to draw squares with different colors. So how to do that? Inside the body of the loop, I will call square with L, which is the loop index here as the argument. By the way, just because I defined the function with the argument L does not mean I have to call it with an argument L. I can call it with any variable I want, even a constant or any variable whose value is already defined and makes sense as a length. For C, what I will do is I will borrow the idea from the last lecture. I will choose to take the ith element. Now this becomes a bit tricky, because what I want is the list should keep on changing colors, but I have only 3 colors. So let's, for the time being, just try L%3. It will not give me necessarily a regular sequence of colors, but it will give me valid indices. After all, at the beginning L is 100. L%3 is a remainder when you divide 100 by 3. That's 1. The next time around, you are adding 10 to L, but 110 has a remainder of 2 when you divide by 3. So that will give you the next one. The first line will correspond to colors 1, which of course is blue. The next square will be green. The next one will correspond to colors 0, because 120 is of course perfectly divisible by 3, leaving a remainder of 0. So we'll get a red square and so on. So this will work out. And let's see. Blue, green, red, blue, green, red, and so on. So the squares are being drawn and they are alternating in color in the fashion that we wanted. Okay, so this loop of course will take some time to complete, because I'm drawing many squares here. And you must agree that even with these simple lines of code, we are ending up with reasonably intricate figures. We will see much more intricate designs in the long run, but for the time being, given the small amount of programming that we have learned so far, this should be quite satisfying. However, it might seem a bit of a bother to keep on specifying both arguments L and C, when most of the time maybe I want a black square. So what I will do is take that into account and define the square function again. This is to demonstrate how to use optional arguments, or how to define functions with optional arguments. So once again, you start with the keyword def, followed by name of the function, then the argument which I have to give. Then of course C is another argument which we want, but what I will do is I will put C equals black here. Now that seems a bit crazy. Oops. Okay, what went wrong of course is that this is a header line. So we define this properly with a colon at the end, and now we repeat the same lines that we had before. Color C for I in range 4 FD L. And of course I don't really need to repeat this, but you must have noticed that I have indented these lines, the body of the for loop, further in, just because this is a compound statement inside a compound statement. And I'm done. Now this square can be called just with one argument, say square 70, let's say, just because I don't want to confuse with whatever squares are already drawn on the canvas. There is a different length, and so a 70 length square has been drawn in black. Why black? Because the argument that I have given here, C, the second argument, has a default value. When I say C equal to black, while defining the function, I do not mean the function only draws black squares. What is meant here is that if the second argument is not specified, if you don't tell the computer, tell the interpreter that what the value of C is, it's going to automatically assume that C is black. Okay, let's reset and set the width back to a large value, let's say 3, so that it's visible. And now let's call square with the length of say 100 and a second argument, let's say red. This means that the second argument value has been given. It's going to override the default value of black, and you are going to get a red square. One nasty side effect of this is that at the end the turtle changes color and becomes red. So if I do nothing else after this, the next line is going to be drawn in red. Of course, that's not true if I draw another square using the square function. Let's say if I draw with say blue, notice that the second argument has been given. C has the value blue now. Inside the function, the color is set by the very first line to blue, and then the square is drawn. So today what we have seen is how to define functions and how to give functions default arguments. Well, actually I could define the function with both arguments being default. Say I could define the function this way. Let's say L is 100, C is black, and then the rest goes the same way as before. I change the pen color, then I go in for the loop and draw a square by going forward through L pixels and turning right 4 times. Now this function square, which is a new function now, has 2 default arguments, both of which have default values, which means I can call it even without any argument. If I don't give an argument, L is 100, taken to be 100 by default, and C is taken to be black. So without any argument, the square function will draw a single black square of side 100. If I give square 90, then I have actually given the value for the first argument, and I have not given a value for the second argument, so it's going to by default draw a black square. Square 90, say 200, comma red. Now I have given values to both the arguments and I am getting a 200-sided red square. Now you might ask yourself, what happens if I wanted to specify the color, but I was happy with the default value L equals 100. Now this will not work, because by default, if you give only part of the arguments, these arguments are all positional. L comes first, C comes next. Positional arguments are just a fancy way of saying the position matters. So if I try calling square with the single argument red, Python will assume that red is the value you want to give the argument L. And it will assume that you have not given the second argument, so C is set to black. If I try calling this, now I get into a problem because it simply doesn't understand how to go forward through a length which is red. So this will not work. But what will work is this. Python actually allows you to use named arguments, which means since you know the name of the argument is C, you can say C equal to red, and then Python understands fully well that you have given. Okay, maybe it's better if I reset the screen a bit and show you this again, because otherwise the square already on the screen will be drawn. But now if I call this, I get a red square. Why? Because now your function had two arguments, both with default values, and here by using the name of the argument C, you have told Python unequivocally, look, take the value of the argument C to be red, and because you have said nothing else, it takes the value of the other argument L to be the default value 100. So now you get a 100-sided red square. There are many more things you can do with functions, and once you have defined a function, you can use it in many useful ways, and we will see more of that in the coming lectures. Bye for now.